Okay. All right. Good day, ma'am, sir. Sir Ken once again. So for today's video, we'll be discussing once again on how to solve Pearson R using the SPSS. Now let's start. So once again, you have to open your SPSS. Okay. Let me just try to close some results here. Okay. Now we have here our SPSS now. So you can see some, I have encoded some datas here a while ago. So yeah. Now let's try to answer some questions here pertaining to the use of Pearson correlation coefficient or the Pearson R. So normally, you would be able to determine if that requires a Pearson or a correlational test if the question starts with or with a is there a significant relationship between the variable 1 and the variable 2 and so on. Okay, so as long as it's asking for the significant relationship, so then either you're going to perform some tests of relationship. Okay. Now, so the question here is there a significant relationship between math scores and English scores? Okay, so I have here the encoded data. Ma'am, sir, the purpose of doing and conducting the Pearson R is to measure the strength of measure the strength and direction of the association or the correlation that exists between the two variables. Okay, which is normally measured at least on an interval or on an interval scale. Okay, now so either so since our data here is falls under into continuous type of data, so which is the math scores and the English scores, so that means we can perform the Pearson correlation coefficient or the Pearson R. So the first assumption, ma'am sir, is our variables must be measured either in an interval or ratio level. So meaning to say they should be continuous. Hindi pwede nga, is there a significant difference between the math score and gender? There is another statistical test that is appropriate for that. But take note, when you are going to perform the Pearson R, it should be two variables, take note, two variables should be measured in continuous, so either it is interval or it is in a ratio level. I hope that one is clear. Another assumption is like there should be no significant outliers. Okay, and it should be normally distributed. So once everything, all of those assumptions were satisfied, so you can then perform the Pearson correlation coefficient. Now to do that in SPSS, so click Analyze. Then you have here to press Correlate. Okay. Then click Bivariate. Okay. There's a new box opened here. So our question once again, is there a significant relationship between math scores and English scores? So you have here to transfer the variables that you are going to correlate. Now, so this is for the math score and the English score. Okay? So then under here, you have to check the Pearson R. You have also here the for Kendall-Stau and the Spearman for non-parametric counterpart. Now, so for this test, we are going to do the Pearson R and click option. There's nothing for you to change here. Then just leave flag significant correlation and two-tailed as is. Okay, so then click OK. All right, so you have here the table now, the correlation table. So as what you can see here, there is the Pearson correlation value, the sig two-tailed, and the n, or this number of samples. So what you just have to report here is the Pearson R value, or this is the sometimes called as the R value, meaning Pearson correlation and the sig or the p value, which is the sig two-tailed. So you have to report the r value, which is 0.481, which is actually flagged as significant to at 0.01. Now, and our sig value here is less than 0.05, so meaning to say it is significant. Okay, so meaning to say the math scores and English scores has a significant difference. Okay, so that is how you can perform the Pearson correlation. Okay, and there's also a while ago there is a an assumption that you can check about the uh, no significant outliers. So we're able to test this one out. You just have to look for the QQ plot. So you could see here there are no outliers. There are no scores or circles outside of this line. So meaning it's the data is there's no significant outliers in this data set. Okay, so that's it.